Respiratory volume per minute. Respiratory volume per minute is defined as the volume of air breathed in 1 minute. A diver with a respiratory volume per minute of 28 litres, 1 cubic foot, would breathe 28 litres of air, 1 cubic foot, at atmospheric pressure a minute on the surface. At 10 metres or 33 feet, rather at 2 atmospheres of pressure, they would still breathe 28 litres of air, 1 cubic foot a minute, but at double the atmospheric pressure, and so on. Increasing the density of the air also increases the number of molecules we breathe in on every respiratory act, and consequently the consumption in bar or psi a minute also increases. There is a direct relationship between the respiratory volume per minute, the surface air consumption rate, and the capacity of the cylinder. The respiratory volume per minute is equal to the surface air consumption rate multiplied by the cylinder capacity. A 15-litre cylinder has a capacity of 15 litres, 0.5 cubic feet. If the surface air consumption rate were 2 bars, 30 psi a minute, the diver's respiratory volume per minute would be 30 litres a minute, or 1 cubic foot, as 30 psi are at double the atmospheric pressure, 15 psi. As you saw on the open water diver course, the surface air consumption rate changes if the capacity of the cylinder being used varies. This occurs because in reality, only the respiratory volume per minute remains constant. To calculate a new surface air consumption rate when you change the capacity of a cylinder, you can work out from the previous formula that with the metric system, the surface air consumption rate is equal to the respiratory volume per minute divided by the capacity of the cylinder. So if the diver with a respiratory volume per minute of 30 litres, 1 cubic foot, changed from a 15-litre, 0.5 cubic feet capacity cylinder to a 10-litre, 0.33 cubic feet one, their surface air consumption rate would increase from 2 to 3 bar a minute, 30 to 45 psi a minute. The results of dividing the 30 litres, 1 cubic foot a minute, by 10 litres, 0.33 cubic feet. The respiratory volume per minute is not always constant, but varies according to the activity you are doing. For example, it could be 28 litres, 1 cubic foot a minute if you are finning calmly, and drop to 14 litres, 0.5 cubic feet a minute if you stop. Or it could increase to 42 litres, 1.5 cubic feet a minute when doing some strenuous physical activity. Calculating the minimum reserve is easy. Just multiply the surface air consumption rate by the absolute pressure at depth and work out the bars you need to stay for 10 minutes. The diver with a respiratory volume per minute of 30 litres, 1 cubic foot, using a 15-litre, 0.5 cubic feet cylinder has a surface air consumption rate of 2 bar, 30 psi a minute. If the diver goes to a depth of 20 metres, 66 feet, or rather to 3 atmosphere of absolute pressure, they should begin the ascent with at least 60 bars, 900 psi, in the cylinder. Instead, if the same diver used a 10-litre cylinder, they would have a surface air consumption rate of 3 bar, 45 psi a minute. So the diver must begin the ascent when the pressure in the cylinder reaches 90 bar, 1350 psi.